Hi guys, it's Mr. Holding, and I'm just putting a quick video to help with you putting tables in for your Punnet squares for your gene lab assignment. So have a look at this and see, hopefully it'll help you. So basically what I've done here is I've decided, obviously we need to do a male and a female, and I've very creatively come up with the names, man for the male and woman for the female. So it took me all night to think about that, but hopefully it makes sense for you. So what we need to do is we need to cross these. So I've already done my pedigree chart, okay, and I found out that for man, he's going to be either, I'm not sure, but he's either going to be big A, or little a, and the chances of those is a 1 into 1. So he's 50% chance of either of these. Woman, so the female, I worked out that she could be big A, little a, and or little a, and the possibilities are 1 is to 2 is to 1. Okay, so there's a couple of things there. So the first thing I need to do is create a table. So I'm going to do, well, first of all, I'm going to write my my title, table 1, because it's a table, and it happens to be table 1 because it's the first one in my document here. Okay, the second table would be table 2, and so on. I've just called it man versus woman, or cross between man and woman, or cross between whatever. You're obviously going to do that. And the next thing I'm going to do is I'm going to put in my table. Okay, so what I've done is I have, because my ones here, it's a 1 to 1, I have to represent them both once. So big A, little a. This one here, however, I have to do a bit more because I've got 3 options, but it's 1 is to 2 is to 1. So this one has to be represented 1 time, this one has to be represented 1 time, but this one has to be represented twice. Now that's the one where people most commonly come unstuck, because they just do this one, this once, and this once, and they fail to recognize that that needs to be represented twice. Okay, so hence I've got 8 spaces. Big A, little a, little a, little a again. Sorry, big A, little a, little a again, and then finally little a, little a. Okay, so we'll put them in. All right. So I did them earlier. So we end up with our, I also put my titles here, or the names of my sire and the name of my dam. Okay, so the male and female, and I put them in there. All I need to do now is making sure that I do it. You may have noticed before that autocorrect sometimes buggers these up, so make sure you check them after you write them in, because you don't want to get stuffed up by autocorrect, and then you want to go and fill them in. Okay, so I've gone and done that, and I've ended up with a situation where I've got all my possibilities here. So here are all the possible outcomes if I crossed man and woman, the male and the female, based on these things here. Okay, from here I can then go and work out my genotypic ratio and my phenotypic ratio. So my genotypic ratio, okay, the possibilities are big A, little a, or little a, okay, and I count them up, and I end up with a situation of 8 is to 16 is to 8, okay, but when I simplify that, 1 is to 2 is to 1. Okay, so basically when man and woman are crossed, the two, whatever they are, let's call them cats, the genotypic ratio is 1 is to 2 is to 1. I can now look at that and go, well, I know that the disease I'm talking about is recessive. So in order to have the disease, you have to have this one here, which means these two here are going to be disease-free. So if I use the phenotypic ratio of non-diseased to diseased, I'll end up with 3 is to 1. So there's 3 out of 4 chance that these possible offsprings are not going to present with a disease. They may be a carrier, but they don't present with it, and a 1 out of 4 that it's diseased. From these, I can then go and work out my my percentages, and I put it in and go from there. So I'll end up with a sentence something like this. So therefore, the litter of man versus woman will result in a 75% chance of offspring without disease, How do I do that? There's 3 out of possible 4. So 3 divided by 4 times 100 will give me 75%. And then 25% chance of offspring with the disease. How do I do that? 1 divided by 4 times 100. I got the 4 from adding those two together, and then I end up with a 25% chance. Okay, so that's the process I do. This is all the information you need to provide in section 5 of your assignment, but you need to do it 3 times. Okay, one for Black Widow versus Black Widow and Black Panther, one for Black Widow and Flash, and one for Black Widow and Kano. Okay, once you've done that, you need to then decide on which is the best option. You do that by having a look at these percentages. Obviously, you want to have as many offspring that are free of the disease. So you're looking for the highest percentage chance of offspring without the disease, and the smallest chance of offspring with it. So you want to have a big chance of the offspring without it, and a small chance of it with it. Okay. Hopefully you found this helpful. If you have any questions, come and see me.